In this video, we're going to take notes on solving polynomials by factoring. So step 1 is to get all terms on one side of the equal sign. Step 2, we want to factor everything completely. Step 3, we want to set each factor that includes a variable equal to 0, solve each one of those equations, and then we can check to make sure we have the correct number of solutions to our polynomial, because we know the number of solutions is going to equal the degree of our function. So let's take a look at this first example. We have x cubed plus 9x squared equals 0. So it's a binomial. It's not a difference of squares because I have a cube right there. So I know that wouldn't work. And it's not a difference of anything. So that wouldn't work. And then this is not a perfect cube and 9 is not a perfect cube. So what I notice is I could take out a greatest common factor. So I'm going to write that GCF is the type of factoring I'm going to use. So I could divide each one of these by the largest common factor they have, which in this case is x squared. But we don't want to get rid of it, so we want to write it out front. We're just rewriting this polynomial in factored form. So don't divide it completely away. And so I would say x squared, when I take that out, x would be left over, and then 9 would be left over from the second term. Then those are equal to 0. So then you want to set each factor equal to 0 and solve. So I would say x squared equals 0 and x plus 9 equals 0 are my two little equations that I get after I factored it out. And then I just have to solve each one. So if I take the square root of both sides, I just get x equals plus or minus the square root of 0, which is just 0. And then I would subtract 9 on this other equation, and I get x equals negative 9. Now, technically, I need to have 3 solutions because my highest degree goes with my highest exponent of all my terms. So I do kind of need to include the negative 0 to be technical right there. And that's how I end up with 3 solutions. I have 0, negative 0, which I know sounds a little weird, but it's okay. And then x equals negative 9. So 3 solutions, and my degree was equal to 3. It was a cubic function. All right, let's take a look at another one. So number 2, I notice is a trinomial. So some other things would not work. Like I can't do difference of squares because that's a binomial type of factoring. And I can't do sum or difference of cubes because that's also for binomials. So I could first check to see if I have a greatest common factor. And I do notice that I could divide all of these by 4. But I'm just trying to factor it out, so I don't want to divide out the 4 by dividing by 0 over here. That's what I mean by divide it out. I want to keep it because I'm just going to write it in factored form. So let's take out the 4, and we would have 2x squared minus 4 minus 7x. And then keep the 0 over there on the other side of the equal sign. But I notice this is not written in standard form right here. So before I go any further, I'm going to put this into standard form. It's kind of our standard trinomial quadratic form. Ax squared plus bx plus c, where we have the quadratic term first, followed by the linear term and the constant term. And it just helps us to factor it out a lot easier to put it in that form. So 4 stays out front as my greatest common factor. I have 2x squared minus 7x minus 4 is equal to 0. And now I want to factor this trinomial. So I see that I have a trinomial where a is not equal to 1, it's equal to 2. So I'm going to take 2 times negative 4, which gives me negative 8. And I got to find numbers that will multiply to give me negative 8 and also add up to my middle term coefficient, which is negative 7. So negative 8 times 1 gives me negative 8, and negative 8 plus 1 would give me negative 7. So I'm going to do wrong way factoring to factor this trinomial. So I take the first term and I write it twice, but I know that that's technically wrong, so I'm going to fix it in a minute. So I put 2x in both parentheses, and then I put these factors that I figured out are going to work to multiply to give me negative 8 and also add up to negative 7. So let's put minus 8 and plus 1. And then I just have to divide out one of those extra 2's because I have too many. Because 2x squared times 2x, or excuse me, 2x times 2x would give me 4x squared, but I only need it to give me back the 2x squared. So we're just going to divide out a 2 in this first group because it'll divide evenly. And I only need to take out 1, 2. So I would be left with 4, and then I would have x minus 4 left from that group, and then 2x plus 1. But now I've got my trinomial factored, and I can take each factor that has a variable in it, so just these two, and set them equal to 0 and finish solving. So I would say x minus 4 equals 0, and 2x plus 1 equals 0. Then I'm going to add the 4, and I get x equals 4. And let's subtract the 1, so we get 2x equals negative 1. And then divide both sides by 2, so x equals negative 1/2. So let's check if we have the right number of solutions. I see I have a degree of 2. That was my highest exponent. And I have 2 solutions. So 2 solutions sounds right because my degree is equal to 2. This was a quadratic function. All right, let's look at another one. So for this one, I see another binomial. So I think of things like, can I take a greatest common factor out? Can I do difference of 2 squares or sum and difference of cubes? So the first thing I notice is I do have a greatest common factor. And I think all 3 of these have had that so far. So you always want to start with that if you can, because it makes your problem more like simplified, and it also makes it correct. So for more than one reason, you want to start with that if you can. So I am going to divide out a 2x and keep it out front when I rewrite it. So 2x to the 4th divided by 2x would leave me with x cubed. And then 128x divided by 2x would leave me with 64. But then I noticed that what is left over is a difference of cubes. So I could keep going because I want to factor it completely. So let's go ahead and factor our difference of cubes and just leave that greatest common factor out front. So I'm going to set up a binomial and a trinomial factor. I'm going to take the cube root of x cubed, and I get x. The cube root of 64 would give me 4. Then I have to square the first term to get the first term in my trinomial, so that'll be x squared. I have to square the last term in the binomial to get the last term in the trinomial, so that's 16. And then I have to multiply them together and put that term in the middle, so that'll just be 4x. Then my signs always follow a pattern. So if I started with negative, then I know my signs are going to be minus, plus, plus. So I'm going to put a minus in the binomial and 2 positives in my trinomial. But now we have to set each factor equal to 0 that has a variable. So that's 3 different factors in this case. I have 2x, I have x minus 4, and I have this trinomial x squared plus 4x plus 16. So I'm going to say 2x equals 0. I'm going to go ahead and divide out the 2 and get x equals 0 as one of my solutions. And then x minus 4 equals 0. I'm going to add the 4, and I get x equals 4 as another solution. And then I've got x squared plus 4x plus 16, and that looks like a trinomial. I need to set that equal to 0. And I need to see, are there numbers that will multiply to give me 16 and add up to give me 4? So 16 comes from 4 times 4, 2 times 8, and 1 times 16. So no combination of that would help me add up to get 4. So factoring is not going to work for this one. So what we should do is the quadratic formula. So we just have to pick out our a, b, and c and plug them in. So we know a is the coefficient of our quadratic term, so that's 1. B is the coefficient of the linear term, so that would be 4. And C is our constant term, which is 16. And then we're going to write out the quadratic formula and plug everything in and simplify. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And then we just got to plug everything in carefully. So x would equal negative b, and b was 4, so that'll be negative 4 plus or minus the square root of b squared. So again, b was equal to 4. So I'm going to square it. Minus 4 times a, which was 1, and c, which is 16. Then all of that is divided by 2 times a, which is 1. Now let's clean everything up. So we get x equals negative 4 plus or minus the square root. And then inside of my square root, I see I have 4 squared, which is 16. And I have negative 4 times 1 times 16, which is negative 64. And 16 minus 64 is negative 48. So that's what I've got to put under here for my simplified form. So I'm getting it all simplified. Then I want to think of the square root of negative 48 for a minute by itself. And how can I rewrite that? So the negative is equal to the square root of negative 1. And then that would be times the square root of 48. Then 48 divides evenly by 3 and 16. And what's good about those numbers is 16 is a perfect square, so I can take it out. So I have negative 4 plus or minus, and then the square root of 16 and the square root of negative 1 is going to be 4i, and then the square root of 3 is still left over. And then I still have that 2 in my denominator. And then I can just simplify this a little bit further because the numbers in the front are going to reduce. They're all going to divide evenly by 2. So I would have negative 2 plus or minus 2i square root 3 all over 2. Or excuse me, all over 1, because I've used up that 2. So let's check and make sure I have the right number of solutions. So I started this problem with a degree of 4. I found x equals 0 was one solution. X equals 4 was my second solution. And then these are actually two different solutions. One is positive and one is negative. So I do have my 4 solutions. 2 are real and 2 are complex solutions, but I do have 4 total. So that's good for number 3. I know that one took a little bit of work to get all the way there, but we made it. Let's take a look at number 4. 4 says 3x cubed minus 6x squared minus 9x equals 0. So the first thing we're going to do is look for a greatest common factor. So let's see. It looks like they all divide evenly by 3x. So let's start by taking out a 3x from each term and leave it out front. So I would have 3x, then x squared is left over, minus 2x minus 3. And then that's a basic trinomial. So we're trying to figure out what numbers would multiply to give us the negative 3 and add up to give us the middle term's coefficient of negative 2. And we're trying to see if that'll work. So negative 3 comes from negative 3 times 1, which would also add up to negative 2. So we just have to write that out as x minus 3, x plus 1, and then that factored nicely. And so now we can set each one of those factors that has a variable in it equal to 0. So 3x equals 0, x minus 3 equals 0, and x plus 1 equals 0. And then divide by 3 on both sides, so we get x equals 0. We can add 3 and get x equals 3 for our next solution. And then we can subtract 1 and we get x equals negative 1. And then check and make sure you have the right number of solutions. So I see I have a degree of 3. And I have 0, 3, and negative 1 are 3 real solutions. So all that looks great for number 4. And that's it for a few examples of how to solve a polynomial by factoring.